Today, we're diving into a scientific cold case that's almost 2,000 years old. It's a tale of two universes, a battle for the very heart of the cosmos. And it's a story about a brilliant idea that was lost, and a cosmic theory that was wrong, but won anyway, for over 1,000 years.
So let me just ask you this. Who first figured out that the Earth revolves around the Sun? I bet 9 out of 10 of you would say Nicholas Copernicus, and that's a great answer. But what if I told you the right idea popped up almost 1,800 years before him? Yeah, to understand how that could even happen, we have to go way back to ancient Greece, where two very different ideas about the universe were about to go head-to-head.
So in one corner, you've got geocentrism. This is the idea that just feels right, you know? A solid, stationary Earth sits right in the middle of everything. And in the other corner, you have the radical, wild idea of heliocentrism, a universe with the sun at its core. For more than 12 centuries, one of these ideas would completely dominate science, while the other, well, it was basically lost to history.
To find the real origin story of the sun-centered universe, we gotta hop in a time machine and head back to the 3rd century BC, to the Greek island of Samos. This is where we meet our first champion in this cosmic fight, a mathematician and astronomer named Aristarchus.
Now here's the crazy part. Aristarchus literally wrote the book on his sun-centered theory, but that book is gone. It's been lost to history. The only reason we even know about his incredible idea is because other geniuses, like the great mathematician Archimedes, wrote about it. This quote right here, this is basically our only direct evidence of Aristarchus' revolutionary theory.
So how did he come up with this?
Well, this wasn't some wild guess he just threw out there.
No, it was based on some seriously clever observation and math. He figured out that when the moon is exactly half full, the Earth, moon, and sun make a perfect right-angle triangle. And if you can measure the angle between the sun and moon in the sky, you can use some basic geometry to figure out how much farther away the sun is. Brilliant, right?
And that simple observation led to a mind-blowing insight. Aristarchus calculated that the sun was about 19 times farther away from us than the moon. Now, okay, he was a little off. The real number is closer to 400, but that's not the point. His logic was absolutely perfect. He correctly realized the sun had to be way, way bigger than the Earth. And to him, it just made total sense for the little guy, Earth, to be orbiting the giant, the sun.
But an idea like this, it was radical. It was unsettling. Heck, it was even seen as dangerous. The Stoic philosopher Cleanthes actually said Aristarchus should be charged with a crime against religion for, quote, putting the Earth in motion. Suggesting the Earth wasn't the center of everything challenged philosophy, it challenged common sense, and it really freaked people out. And so, the idea just fizzled.
With Aristarchus' theory pushed to the side, the stage was now set for a totally different model to take over. So let's jump forward about 400 years to the 2nd century AD, in Alexandria, Egypt. This is where we meet the man whose work would become the undisputed law of the cosmos for over a millennium, Claudius Ptolemy.
Ptolemy wrote what is easily one of the most influential science books of all time. It eventually became known by its Arabic name, the Almagest, which literally just means the greatest. And for centuries, that's exactly what it was. It was the authority.
Ptolemy's universe was built on a foundation of pure common sense. I mean, think about it. The stars and planets all seem to move around us, but we don't feel the Earth spinning or flying through space, right? It was this elegant, intuitive picture of the universe that just confirmed what people saw with their own 2 eyes every single day.
Now, the biggest headache for ancient astronomers was this weird thing planets do called retrograde motion, where they seem to stop, go backward for a bit, and then move forward again. To solve this puzzle, Ptolemy came up with this incredibly clever system. He imagined planets moving in little circles, which he called epicycles, that were themselves moving along bigger circles around the Earth. It sounds complicated, and it was, but this circles-on-circles machine was amazing at predicting where the planets would be.
And the Almagest was a beast. It was incredibly comprehensive. This wasn't just some vague theory. It was a complete 13-book instruction manual for the entire universe. It laid out the math for the sun, the moon, retrograde motion, and even included a catalog of over 1,000 stars. If you had a question about the cosmos, the Almagest had the answer.
Okay, so this brings us to the big, central question of this whole story. We had Aristarchus, who was basically right, and Ptolemy, who was wrong. So why on earth did the wrong idea win and dominate science for over 1,200 years?
Well, there were actually 3 very good, very scientific reasons. First, and this is a huge one, Ptolemy's system worked. It predicted where the planets would be with amazing accuracy. Second, it fit perfectly with the physics of the day from guys like Aristotle. And third, here's the killer argument. If the Earth was actually moving through space, then the nearby stars should seem to shift their position against the distant background stars. It's an effect called stellar parallax. But no matter how hard they looked, they couldn't see it. And for them, that was stone-cold proof that the Earth stood still.
For centuries, Ptolemy was a legend, a giant of science. But in our modern era, his reputation has taken a massive hit, with some scholars throwing out a pretty shocking accusation.
So who was Claudius Ptolemy? Really? Was he one of the greatest scientists ever? A guy who pulled together all of ancient astronomy into one beautiful system? Or was he a fraud who faked his data to make his theories look better than they were?
Back in 1977, a physicist named Robert Newton published a book with a title that pulled no punches, The Crime of Claudius Ptolemy. His argument was that Ptolemy didn't really make his own observations. Instead, he claimed Ptolemy took data from earlier astronomers and basically cooked the books, fudging the numbers so they'd perfectly match his model.
But hold on, because that fraud label is super controversial. While pretty much everyone agrees that some of Ptolemy's data looks a little too perfect, a lot of historians push back hard against the accusation. They argue that the Almagest was never meant to be a raw data log. It was a theoretical masterpiece, a synthesis of everything that came before. It's a debate that's still going on today.
So, how did this ancient battle of ideas finally come to an end? Well, for the answer, we have to leap forward in time to the dawn of the scientific revolution.
I mean, just look at this timeline. It really puts it all into perspective. You've got Aristarchus with the sun-centered idea way back in 270 BC. Then almost 1,800 years, 18 centuries, go by before Copernicus finally brings the idea back to life. That is an almost unbelievable amount of time for a correct idea to just sit on a shelf.
It's almost as if science itself experienced its own kind of retrograde motion. It followed a path that seemed to be moving forward, but was actually taking a huge, long detour before finally correcting its course and surging ahead again.
And this really is the key takeaway. Copernicus wasn't the first person to have this idea. What he did was revive a brilliant, ancient one, and for the very first time, he gave it the same mathematical rigor that Ptolemy had given to the wrong idea. And in doing that, he finally gave it the power it needed to win the debate and change humanity's place in the universe forever.
And that kind of leaves you with a pretty big question, doesn't it? The story of Aristarchus is about a great idea that was lost and then found again. It really makes you wonder, how many other brilliant insights are out there, buried in old books, just waiting for their own Copernicus to come along and rediscover them?